We're talking about integration of tangent to the m of x, secant to the n of x, dx when both are odd. Now, this is a disclaimer. I just wanted you guys to know that the integral of tangent to the m of x, secant to the n of x, dx, well, that is similar. Yes, there's a few differences in terms of negatives and stuff like that, but this is similar to cosecant to the m of x, cotangent to the n of x, dx. Okay, so I just wanted you guys to know that. And so what if we're dealing with tangent to the m of x and secant to the n of x when both are odd, okay? The first line of defense I usually look for is the idea of u substitution. And so what if we're given this integral and we're asked to integrate it? Well, again, the first thing I usually look for is u substitution. And so if I look at this, if I set my tangent to be u, then the derivative of that is secant squared. We actually have secant cubed, so that would not work. And then if I set my u to be secant of x, the derivative of that is actually secant of x tangent of x, which currently in this one we do not have. And so my second line of defense is actually rewrite the integral and borrow one from both, okay? And so this is a 3, so I want to be clear, and borrow one from both. And so if I look at this, this now becomes the integral of secant squared of x times, well, in this case, because I only have one tangent, I cannot borrow. And so tangent will just stay like it is. So this becomes secant of x, tangent of x dx, okay? And so now we can see something different. If I set my u to be secant of x, I actually have the derivative here, okay? And so if my u becomes secant of x, then my du is actually secant of x, tangent of x dx, okay? So I could rewrite this integral as u squared du. If I take the integral of that, that is just 1/3. Well, what's my u? That happens to be secant of x, that we secant cube of x plus c. Okay, so whenever they're both odd, the first line of defense is u substitution. If I cannot, I'm going to borrow one from each. It just so happens in this case, my tangent, I only had one tangent, so that had to stay as how it is. Okay, so let's look at one more. So what if we wanted to take the integral of tangent to the cube of x times secant to the fifth of x dx? Okay, how would we integrate it? Well, it looks to me that if I set u to be secant of x, I don't have its derivative. If I set u to be tangent of x, well, that's just secant squared of x. I have secant to the fifth of x, so that would not work. So u substitution do not work. So what do I go to? Split and borrow one from each. So I could rewrite this integral as the integral of tangent squared of x times secant to the fourth of x multiplied by secant of x tangent of x dx. Okay, so notice I just borrowed one from both. Okay, now what it looks to me is if I have the derivative of secant of x. Okay, so if I have the derivative of secant of x and I don't need tangent anymore. Okay, I just need a u simple u. So I'm looking at this point, looking at u substitution. If I set u to be secant squared, if I set u to be secant of x, well, I have secant of x tangent of x, which is a derivative, but I don't have tangent squared of x. And so in this case, we got to fix this. So we could fix this by using the identity, okay? And so we know tangent squared of x, that happens to be secant squared of x minus 1. And that is multiplied by secant to the fourth of x times secant of x tangent of x dx. Okay, and now I could just distribute my secant fourth. So this becomes the integral of secant. I have the same base, I just add my exponents. So this becomes secant to the sixth of x minus secant to the fourth of x. And we're going to multiply that by secant of x tangent of x dx. Okay, now my whole integral now it becomes in terms of secant, and that fixes everything. So now if I set u to be secant of x, then my derivative, or du, becomes secant of x tangent of x dx, which is exactly what we have here. And so we could rewrite this integral as u to the sixth minus u to the fourth du. okay, and take an integral of that, that becomes 1/7. Well, what was my u? It becomes secant. So this becomes secant to the 7th of x. Okay. So that becomes secant to the 7th of x. Okay. Minus, well, what's the integral of u to the 4th? That's just 1/5 u to the 5th. So that becomes 1/5. Well, what was my u? Secant to the 5th of x plus c. Okay. And this is my integral. And this is my integral. So again, general idea is u substitution, first line defense. If you cannot, you break it down, split one from each, okay? Split one from each, and then you try to use u substitution. Now, in this case, you could see that here when I split, I pretty much had my derivative, okay, and nothing else in the integral. So I did not have to worry about identities, but whenever we split, and we see the secant of x tangent of x here, and it's very trivial that you'll see this, okay? You have to know that if I want to get the if I want to do u substitution, the whole integral has to be in secant. It has to be in secant, okay? It has to be in secant, so we got to use our identity, and so that will work. Because if we did it from this point, well, that would be wrong. Because again, if we set u to be secant of x, we have its derivative, but we also have this tangent here, which we actually do not need. So that's why we actually use this identity to get rid of that.